Good morning, everybody. Our first speaker is Pierre Lauber with SLR-System upgrade and experiments at Zimmerwald.
Good morning, everybody. The title is SLR-System upgrade and experiments at the Zimmerwald Observatory. It doesn't work. It's still switched on. Pressing more button. Okay. Just to give a short overview, there are two parts. This is the system, the SLR-System upgrade with some new devices, buildings, and so on. Or buildings, it's a little bit too much. Devices, especially in the part B, with some experiments about quantum communication. So it was required that we have to change our dome because the old dome was 40 years old, no longer state-of-the-art, had security problems. So we had to replace it. And the old one was an all-sky dome. Now we changed to a slit dome. This has advantages and, of course, also disadvantages during our current energy crisis, I would say. Now I have to, during observations, I need a bicycle. I have to turn the wheels and to generate some more electricity to drive the azimuth. So, because we already knew that we are replacing the dome, we also did some other things. We replaced the cooling, the entire cooling system of the station, because this was also, I would say, 20 years old. And also because the old system was using another cooling fluid. So we changed, also due to new national regulations, to water. And maybe just to let you know, if you would like to change to water, there are also some disadvantages compared to the old critical fluid. This is now, of course, water has a problem, or electricity has a problem with water. And you have to keep this in mind. And the devices, cooling devices, are getting bigger. And just this was the wrong direction. And also the hoses around to the devices and so on, everything is getting bigger. Then we also have made new thermal isolations of the walls and of the coude room. By the way, we changed maybe last year already the unbreakable power supply of the entire station. We have now one complete for the entire station. Before we had at every PC or whatever, we had special UPS. We replaced the compressor. Also a very old 24-volt DC UPS has been replaced. This is the one which I did by myself, and also this is used, a clone of it is used for the Mesa. So, we are, since end of February, we had bad luck. The electronics of our derotating shutter stopped working, and from this time on, we tried to get the system up again, but the delivery times of the electronics was already 3 weeks or whatever. So, and we started in March with the work with replacing of the dome. So we were not yet able to start the system, the SLR system again. And since with the dome, since last Thursday, now we got a firmware upgrade from the Bader dome. So we are now since some days able to move to operate the dome only, but there are, since that time, since all these months, we lost also some other devices. The maser, the ion pumps do not longer work. So after running of 6 years, also the laser chiller cooling flow controller stopped working. So we had to replace it. It was a really easy thing. Some movable devices, they also stopped due to adhesion, and when moving them several times, it's working again. But we have currently a real showstopper, maybe due to you can call it downtime damage, I don't know. Also could be due to usual aging. Our laser oscillator is some kind of damage. It doesn't provide enough output signal peaks, and also the average power is lower than it should be. We do not really know what was the reason. There was some things around with the temperature was not stable as it ought to be. Usually we have in the laser room 22 degrees, but due to all this work with the cooling system, it was out of the standard value. So we will hope that we will back with all the other things with this laser again, but we have good news, already 2 other lasers bought. One for the geodetic use. This is the geodetic use means enough precision for the SLR, and we have another one for space debris use with high pulse width, and so not so precise measurements, but with high energy. The interesting thing is, compared to our Thales laser, these lasers are some kind of standard versions from the manufacturers. So the Thales laser was made for, especially with a real specification list made for us, and these are some kind of stock and only some slight changes. So now the part B of the presentation, we made some quantum experiments of quantum communication at the station, and there are also 2 different things. There were 2 different things. This was called the campaign Vertigo. So the thing is, Zimmerwald acted as a host for guests, and we provided some infrastructure, only some limited room, help and power, Ethernet, also access to the Zimmerwald air traffic control system, so they can really connect and to a server and asking the server whether they can fire with their laser into that direction, and the system knows whether there is an aircraft or not. With this special campaign, this Vertigo campaign, we had a lot of partners. These were Thales Alenia Space from Zurich and Toulouse, ETH Zurich. We had Honora close to Paris, Fraunhofer Heinrich Hertz Institute Berlin, and as an additional user, University of Geneva. And so they were trying their experiments at the station and did some quantum communication from Zimmerwald to the Jungfrau Joch, which is about 50 kilometers away from the station. And the good thing is that there is an within the university campus internet, a direct link between this Jungfrau Joch and the University of Bern and also Zimmerwald, and they can use it and take advantage of this. So yeah, they were using their own telescope within a container, and set up everything, adaptive optics and so on, had their own detectors for quantum key distribution, quantum keyless, whatever. I do not know all these different methods they were using, and they were really able to do some experiments. Maybe just to note, this is a almost horizontal link, and it's attenuated by these 50 kilometers of humidity, which is quite a lot. The other experiments, the second part, which is where our Astronomical Institute is more involved, is we called it drone flights. The idea was to have some quantum communication to a balloon with a payload of some experiments, and the thing is, there are different quantum communication techniques, and this one here, developed by University of Geneva and University of Barcelona, is trying to get some things more simple and more rugged, because usually the one problem with these photon entangled things is they do not have enough power for such a link here, and they decreased the lobes of both systems. And also changed the type of this quantum technology. They call it more modulation than a coding technique, but it's not so important. Page is always working the wrong direction. And the thing is, on the payload balloon or drone, whatever, there are different links, 3 links especially. There are 2 optical links. We are using the standard SLR link, as we usually use from the station, from the SLR-System. Then there is a second link with a communication link from the balloon or from the drone down to the station. It's implemented by University of Geneva and Northwest Schweiz. And there is a third link with GPS data. There is a GPS receiver on board of the drone or balloon, and it sends out the current position of the balloon or drone. And at the station, this position of the drone balloon is received, and the telescope is slewed towards this drone or balloon position. So this is the drone. Maybe we bought already, I think, a newer, bigger one, so that we can carry a higher, heavier load, and it should be equipped with reed reflector, breadboard for the optics, the laser, the QKD-P encoder, electronics, batteries, of course, very heavy batteries, so that you can fly it with some minutes at least, with all these things. The GPS receiver, the Raspberry Pi, and the gimbal. The gimbal, you know, maybe from cameras. It's so that you can it should tilt to the station, so you program the position, and whatever the drone is moving due to wind or whatever, the position you're pointing to the station remains the same. This is important for the downlink.
Pierre, you have about 2 minutes left, just for timing purposes.
Okay, yeah. Then, just a very small outlook. We want to be back with standard SLR, hopefully, in some weeks, if we have fixed the problem with our laser oscillator, and we will proceed our quantum communication experiments, of course. And we did not yet have accomplished everything what we wanted. So And then thank you very much for your attendance.
Thank you very much, Pierre. Any questions from the audience, or?
Hi, just a quick one. What sort of temperature stability do you get with your new cooling system in the laser room and Coude room?
Yeah, before we had split devices, and the National Agency for Buildings and Estates in Switzerland, they don't want that we have these split devices and with this old cooling fluid which is responsible for the ozone problem in the troposphere. And so I would say in all the rooms they have removed these old devices. We have rack cooling, for example, and we had before already water for this, and so the new cooling devices are connected again or now to also this cooling circuit, and they also increased the cooling power of the system.
So, but you achieved better stability than you did with the old split air conditioning systems. Is it actually an improvement as well?
Yes, I would say so.
Okay,
yes.
Thank you.
We have one back here.
Yeah, I have a general question. Why do you want to do the demonstration on a drone instead of like a ground target? What's really scientifically what you get out of it?
Yeah, I think on a ground target this is too easy, and the thing is, some years ago the Chinese people did already such experiments on a satellite, on a LEO satellite. I think it was called Mercurius, and the ESA especially, I think they are underdeveloped using for these quantum communication experiments, and so we were pushing these things now, and it has to be a moving target. And before doing this on a satellite, the first two steps is do it on a drone and then on a balloon. The problem with the balloon, of course, is already you cannot control it easily, and so this was the starting point.